This video is on the objective use the law of sines to solve ASA or AAS triangles. Now ASA is angle side angle, where you're given two angle measures and the side between them, the side they share. AAS is angle angle side, where you know two angle measures and then one of the sides that's not between them. And in either case, you can apply the law of sines to solve the triangle. Alright, so this is not actually from my this is not from the preview of the assignment, because for some reason I couldn't see this kind of a question in my preview, and I tried going through it again. So this isn't one where you have, this isn't, you'll see a question like this perhaps. And if you do, great. I'm just glad I've gone over at least one like this. If you want to see more about the topic, of course, click on More Instruction. Right? It'll be this one's not from the assignment again. It'll be at the bottom of the problem. Remember, there's More Instruction, and look at their videos, their notes, their examples, and hopefully those help you out. All right, so here we're given a picture of a triangle. In triangle ABC, we're told that little b has a length of 13. Angle B has a measure of 54 degrees, and angle C has a measure of 43 degrees. Solve for little a and little c. Basically, I'm just going to solve the triangle here. Alright, so I'm going to draw this up on a separate piece of paper and go over that. Alright, so here's a drawing of that picture they gave us. Again, this is the angle side case, or the AAS case. And in the AAS case, ASA case, or SSA case, we can apply the law of sines to try solving the triangle, find all the missing pieces. I'm going to tell you right now, in AAS and ASA, you are given two angle measures. So if you're given two angle measures, the third angle measure should be easy to find, right? Finding the measure of angle A should be easy. Because remember, all three triangle angles, right? All three angles in a triangle on the plane should add up to 180 degrees. So if I want to find the measure of angle A, take 180 degrees and then subtract, these two, angle B and angle C, minus 54, minus 43. Now 54 and 43 make 97. Alright, they make 97. So angle A needs to be 83 degrees, right, for all three to add up to 180. Right. Okay, and again, you can double check by add them up. They should add up to 180. And this is the case also for the ASA triangles, right? You'll have two angle measures, so you could easily find the third. Okay, now we're going to use the law of sines. Right. Let's start off by finding, now that I have angle A, I should now be able to find little a, right, side little a. And remember, the law of sines states the following. Side little a divided by the sine of angle A. All right, basically, the ratio of a side to the sine of its opposite angle. This ratio is the same for every side and every opposite angle. So this will be equal to little b divided by the sine of angle B. And both of these will be equal to little c divided by the sine of angle C. And you could also flip these, right? Have the sines of the angles in the numerators, just so long as you're consistent, right? As long as the side lengths are in the numerators, or the sines of the angles are in the numerators, right? Whichever one you want to use. I'm only going to pick two of them, right? Just want to write one equation where, the only missing piece is side A. So again, I know angle A, I'm trying to find side A, and I know both of the B stuff, right? So I'll use this. Little a, I don't know, divided by the sine of angle A, right, the sine of 83 degrees. This should be equal to, and then again I'll use the b stuff. Little b is 13 units, divided by the sine of angle B is 54 degrees. And then to get little a alone, I would just simply multiply by the sine of 83. So little a is 13 times the sine of 83 degrees over the sine of 54 degrees. All right, this is all great. I mean, this is the side length of A, but we're going to put this in our calculator, round it. It looks like they're rounding in the answers here to 2 decimal places. So I'm going to pull my calculator up. My angles are in degrees here, so I'm going to go to mode and make sure, all right, I'm in degree mode, great. Then we'll do 13 times the sine of 83 divided by the sine of 54. And we're getting about, to 2 decimal places, that would be 15.95 if I rounded to 2 decimal places. All right, so I'm going to put that on my picture. This is about 15.95 units long. Great. And then I'll do something very similar to find little, the only thing that's missing on the triangle now is the length little c. So now I'm going to find little c, and the same thing, I know the angle c, and now I know both the a stuff and both the b stuff, so I could use either one. It's just, you've heard me probably say this before, I'd rather not use the 15.95. I like to write equations and expressions so that I use as little rounded numbers as possible. So I'm going to stick to using the b information that I was given. All right. So little c divided by the sine of angle c, right, the 43 degrees, is, it should be equal to, and then again the b information, little b at a length of 13 divided by the sine of 54 degrees, angle b. And then just like before, very similar, the only thing that changed was this angle here. I would just, to get little c alone, I would multiply by the sine of 43 degrees. So c would be 13 times the sine of 43 degrees divided by the sine of 54 degrees. And then we'll punch that in and round to, two decimal places. Now the nice thing is, this looks exactly like this, except, instead of 83 degrees, I have 43 degrees. So what I'm going to do on my calculator is just go second, and then previous entry, right? Above the enter button, it says entry, and it puts up what I had previously. I'm just going to scroll back through it and change 83 to 43. So I don't have to retype all that. So the length little c is approximately 10.96 if I round to 2 decimal places. So little c has a length of about 10.96 units long. Right. And let me look at this triangle one more time and just double check that, make sure that the smallest angle has the smallest side opposite it, and the largest angle has the largest side opposite it. All right, so 43 degrees has, the smallest angle. Side C, 10.96, that's the smallest side. So far, so good. The largest angle is 83 degrees, and its opposite side, 15.95, is the longest side. So great. I feel like I did this correct, but 10.96 and 15.95 for these lengths. And you're seeing that again. This is not from the assignment. So you see the 15.95 for A, 10.96 for C is the correct answer of these 4 choices. The bottom one here. And then I'll show you the explanation if you want to pause the video, read through that, you can. Alright, so again, hopefully watching me go over this, looking at the more instruction when necessary, when you feel like you need to, and reading the answer explanations when they come up. Hopefully all this stuff helps you out when you're going over problems in this like this and this type of material on your own. And thank you very much for watching.